Okay, here we're going to talk about an introduction to rational expressions. All a rational expression is an algebraic fraction. The first thing we're going to talk about is undefined fractions. Now, what makes a fraction undefined is when the denominator is equal to 0. So I'm actually just going to underline that to point that out. Okay, so when the denominator is equal to 0. Okay, so let's take a look at some examples. The first one says find the value, or the directions say find the value or values of x that make the fraction undefined. Okay, well, if we wanted to figure out what makes this fraction undefined, you're completely ignoring the numerator, okay? You just ignore this. The numerator does not affect an undefined fraction. What we're going to do, though, is we are going to just figure out what we could replace this x with so that the denominator is equal to 0. All right, so we could see it would be -5 because -5 plus 5 is 0. I mean, if you wanted to make an equation to show this, you could just take the denominator, set it equal to 0, and solve. So we wind up with x equals 5. This is the value that makes our fraction undefined. Okay, now if we look at number 2, this one may not be as easy to just look at and say, oh, all right, well, here's my value of x that makes the denominator undefined. So why don't we just start this off the same way we did over here with number 1. Let's just ignore the numerator, and let's just take our denominator and set it equal to 0. Okay, so if we're going to solve this, I'm just going to factor it. So you could either factor out a 3 if you want, or kind of a shortcut so you could just get rid of that 3 altogether is you can divide both sides of the equation by 3, and then it's no longer there, so you don't have to worry about it. So we're left with x squared minus 7x plus 10 equals 0. Now, if you did keep that 3 on the outside here, that would be okay. Just you'd have a 3, and you would set up parentheses around this. Okay, now I'm going to factor this. Two numbers that multiply to positive 10 and add to negative 7 are negative 5 and negative 2. So now when I solve this time I wind up getting two separate values that would make our fraction undefined. We get positive 5 and positive 2. Okay, now we're going to talk about simplifying fractions or simplifying rational expressions. All right, the directions say simplify the following rational expressions. Okay, we'll get to the second part of the directions in a minute. So in order to simplify this, you can't just go through and start canceling off x squared and x squared and, finding the 2 and the 2. When numbers are connected by addition signs and subtraction signs, you're not allowed to cancel them off. You're only allowed to cancel off things that are being multiplied together. So keep in mind, factors are just what multiplies together to give you that expression. All right, so our first step here is going to be to factor what they give us. All right, so let's start with the numerator. If we were going to factor that, the first thing you could do is factor out the greatest common factor. You could pull out a 2, which would leave you with x squared minus 9. Now, that can be factored further because that's a difference of perfect squares in the parentheses. So let's bring the 2 over, and let's factor that x squared minus 9 to x plus 3, x minus 3. Okay, now in the denominator, this is just a basic trinomial. We just want to come up with two numbers that multiply to negative 15 and that add to positive 2. So x plus 5 and x minus 3. Now I'm just going to bring that over here just so we have this written as one fraction. Okay, now that we have terms being multiplied together, on top we have three factors. We have the 2, the x plus 3, and the x minus 3. In the denominator, we have x plus 5 and x minus 3. So you're allowed to cancel off an entire factor with another factor, so as long as they're the same. So I'm going to take this and cancel off this x minus 3 in the numerator with this x minus 3 in the denominator. Now you're only allowed to cancel off 1 in the numerator with 1 in the denominator, okay? If they were both in the denominator, we wouldn't be able to cancel them off. Okay, so what that leaves us with is in the numerator 2 times x plus 3 over x plus 5. Now keep in mind, I didn't keep these parentheses around my denominator because I didn't need to. It was the only thing there. So you can either write your final answer like this, or if you prefer to distribute the 2 into the parentheses, you can rewrite your numerator as 2x plus 6, and then keep the denominator as is. Okay, now if we go back to the directions, the second part says, then identify the value or values of the variable that must be excluded to prevent division by 0. So basically what they're trying to tell us to do is, identify any values that would make our fraction undefined. So what you do is you go back to the complete factoration of the denominator. So this right here, x plus 5 and x minus 3. If either one of these two factors were equal to 0, then the entire denominator would equal 0, because 0 times anything is 0. So if I were to substitute this x right here with a negative 5 plus 5 is 0, which we're not allowed to have, because if there's a 0 in the denominator of the fraction, we would say that's undefined. So right now I could say x cannot equal negative 5. Also, if we look at the x minus 3, if we replace this x with a 3, 3 minus 3 is 0, which, again, we cannot have in the denominator of the fraction. So to answer the second part of the directions, we would say that x cannot equal negative 5 or negative 3. Okay, let's take a look at one more example. Now again, remember, you're not allowed to just start canceling off. You can't just say, oh, look, here's a 20x squared and a 20x squared. Let me cancel those off. Because this 20x squared is connected to the 4x cubed by a subtraction sign. And same thing down here, okay? It's connected to these terms by subtraction and addition. So what we want to do is we want to factor the numerator and factor the denominator, because once everything is factored, you can cancel off factors with other like factors. Okay, so let's do this. Let's start off with our numerator. All right, so it looks like we could factor out a greatest common factor. We could pull out a 4x squared, and when we do, that's going to leave us with x minus 5. So that's really all we can do in the numerator. Okay, in the denominator, we could first pull out a greatest common factor of 2x, and once we do, it looks like it's going to leave us with x squared minus 10x plus 25. Okay, we can definitely factor that further. So let's just bring our numerator back over. And then bring the 2x over. And two numbers that multiply to 25 and add to negative 10 are negative 5 and negative 5. So we're going to have x minus 5 and x minus 5. Okay, now, one thing I want to point out. You are not allowed to cancel off the x minus 5 in the denominator with the other x minus 5 in the denominator. In order to cancel them, one has to be in the numerator and one has to be in the denominator. So let's cancel off this one with this one. It doesn't matter which one you choose on the bottom. Okay, now, on the top, we have a 4x squared. And on the bottom, we have a 2x. Now, the 4x squared really means, I'm just going to kind of do this off to the side, 4 times x times x. So each of these are really factors. We have a 4 being multiplied by an x being multiplied by another x. On the bottom, the 2x means 2 times x. So these are also factors. So keep in mind, you're allowed, once everything's factored, when everything is separated by multiplication, you're allowed to cancel off. So you can cancel off one of the x's on the bottom, on the top with one of the x's on the bottom, and then really, since there's a number that divides evenly into both of these, right? They both divide evenly by 2. 4 divided by 2 is 2, so I'm going to cross that off and make it a 2. And 2 divided by 2 is 1. I mean, you don't really have to put the 1 there. That's up to you. So just to go back to our problem over here, what I did was you can cross off this 2, and you can make this 4 a 2, and then you can cross off this x on the bottom with one of the x's on top. So I'm just going to get rid of the square. Okay, so now it looks like in the numerator, all we're left with is a 2 and an x, and in the denominator, we're left with an x minus 5. Okay, now if you recall, the directions said to determine any numbers that we would have to exclude, determine any values for x we would have to exclude, because it would create a 0 in the denominator of the fraction. Well, let's go back to this step before we cancel things off. In the denominator, we had a 2x, an x minus 5, and another x minus 5. Well, we would need to figure out what values of x would make this equal to 0. So you can either just look at it and say, well, if I replace this with a 0, 2 times 0 is 0. And if you have a 0 anywhere in the denominator, we can't have that. So we can right away say x cannot equal 0. And then if we look over here, this is an x minus 5. If we replace this x with a 5, 5 minus 5 is 0, so we also cannot have a 5. Now, since this is the same factor, we don't have to rewrite the 5 here again. Okay, once you write it once, that's it. So this is the simplified version of this fraction, but keep in mind, x cannot equal 0 or 5 because that would make our fraction undefined.